Describe for me, if you would, what the apparatus here is, what the project is.
Well, this is polyox 1, and this is the polyox here, and we're trying to test for the elasticity of the polyox. It siphons down through the U-tube and through this clamp, which is our constant, and by measuring the average weight of 20 drops and the time it takes to form the drops, then we can get some idea of the elasticity and also some idea of the surface tension of it. And that's about what this is.
What kind of good is that information? What could maybe it'd be used for?
Well, we don't know right now, but maybe with some of our other tests like viscosity and something like that, we might be able to put it together with that and come up with something new.
What is polyox?
Well, it's a shortened name for polyethylene oxide invented by Union Carbide, and it forms chains. It's polymers do instead of like water, and they connect and they siphon themselves out if you do it right. If you pour it, and they form chains, and this is why it's called anti-gravity substance instead of cutting off. And poly means many, and then ethylene oxide, that's the name of it.
Okay, thank you. Jeff, you're working with the same kind of material, polyox. What's this experiment, if that's the right word, for, and what are you trying to find out?
Well, we're trying to find out the fluid rate of polyox, rate of flow. And if we can find out this, we can extrapolate it out into, say, bigger pipes, etc. And this might be used for irrigation purposes. And what way we do it is we create a vacuum by suction here, siphoning. This creates a vacuum in this receptacle here, and we measure the amount of time it takes for the 250 milliliters of our solution to siphon out. For the vacuum to bring it over to here, and we take the time, write it down. We're going to draw a graph and try to find the optimum solution to pipe through it. Polyox is as good. You could use it to irrigate because it is a part of water.
You think it's possible that you'd find some new use for this material and make a lot of money out of it?
Well, we hope so. I doubt it, but we could try, you know.
Of the work you've done here with it so far, have you been as successful as you wanted to be? Have you run into some problems you didn't expect?
Yeah, well, this is the second part of our experiment. Actually, we had another one set up, but we didn't actually get the right results we wanted, so we went to a second part of the experiment, which is this. What we had a while ago, we were pumping and measuring the height of it, but had a little trouble with pumps and etc., so we had to go here.
Professor Schmidt, in general terms, what is Operation Catapult? What's its purpose?
What we try to do is introduce high school students who think they want engineering and science to the general procedure of conducting a scientific inquiry. Let them have some experience in what would it be, how would you go about setting up equipment, encounter the frustrations that always is part of debugging equipment, and let them find out firsthand, how do you study something you don't know.
The boys here are high school seniors, all of them?
They will be seniors this fall. They have all had at least 2 years of mathematics and either a year of physics or a year of chemistry. And the whole list of projects is designed in the direction of physical science and engineering.
Is this an area that you find most high schools have done good preparation? Do the boys really know what they're going to be doing, going to be getting into when they come here, even for Operation Catapult?
Yes and no, in the sense that they have received good instruction in the objective aspects. By this I mean routine. But as far as putting this to work in studying something they haven't already seen, there just simply has been no opportunity in the high schools, nor time to try it. So we try to let them see what would it be like if you went into this.
Now, how long are they here, and what sort of works do they do?
They're here for about 3.5 weeks. This includes all of the computer instruction which we give to our own entering freshmen. It includes some lectures in the first week on how to go about conducting scientific inquiry. And then we have, the principal part is on projects. They must design their own project, collect their data, and analyze it and come up with some description of the physical properties they've been investigating. In addition to this, we have a list of invited lecturers who come to speak on topics not necessarily at all related to physical science or engineering. And this is done with the thought that the interest a person has at any one time depends on his past experiences. And so he may not be interested in art because he's never heard an artist talk. So we try to get other fields represented.
In a sense, then, this is one way that the young man has of deciding what his career is going to be, or at least how he's going to start. How successful has it been?
To date, the information we have received from the students, their parents, and their teachers has been most encouraging. And some evidence of this is the fact that prior to this summer, we have had 60 boys in each session, and this time we have 70 in each session. And we have been particularly encouraged by the students who have been in this program in past years and then return either to Rose or to some other engineering school, further convinced that's what they want to study. There are some who decide after 3.5 weeks that they definitely do not want engineering or physical science, and we believe that's quite fine. At least they have a better idea what they want to do.